just the voice. Okay, so today we're going to talk about finishing up 2.2. The learning targets were graphing and analyzing polynomial functions, determining end behavior based on degree and leading coefficient, and we probably reviewed that pretty well with the activity, I think. Even degree, both ends go in the same way. Positive if they're up, negative if they're down. If it's odd degree, let's see, this is positive, right hand up, okay? If it's negative, then it's left, but they're going opposite directions. I can determine the possible number of zeros. Do you remember how that goes? If you know the degree, then that's the same as the possible number of zeros, right? Doesn't always mean it's the same, but it's possible. Maximum number of zeros is the same as degree. And turning points, do you remember how that goes? One less, okay? So the degree minus 1 gives you the possible number of turning points. And what are turning points again? Maxes and mins, okay. And then we talked about multiplicity. Multiplicity of a 0 meant like you had a factor. Oh, yeah, let me record it and not even get my tablet hooked up. That was not. Oh, more spill. So if we have an x minus 3, that's a factor, and it has a squared, what is it going to do at 3? What is the graph going to do at 3? Maybe it has an x, it's coming like this, it goes through 0, but when it comes to 3, it's going to bounce because of the even multiplicity. It's going to look like a little baby parabola there. Okay, so that's the idea, and that's what we're going to carry through on writing equations today. All right, so 6A has, I think, 4 examples. We can do all of them or skip one if you want, but there are 4 examples. The first thing you want to do is figure out where the zeros are, and sometimes they're labeled and sometimes they're not, but where it crosses the x-axis. So this has a 0 at -4, is that right? So the factor would look like x plus 4. Is everybody okay with that? If there's a 0 at -1, there's a factor of x plus 1. If there's a 0 at 3, there's a factor of x minus 3. Now, this is currently degree 3 that I have down here. Is our graph a degree 3? Both ends are going the same way, so it needs to be even degree. And most of you may have noticed right away that what's happening here. Now, I have students who are still confused what a bounce is, okay? This one is crossing through there. It goes from negative to positive. Everybody see that at -4 or positive to negative, whichever way you're going. Same at -1. But at 3, it hits the x-axis and it turns around without ever becoming positive or switching sign. That's a bounce, okay? And this one is bouncing. It means it's even degree. We just use 2. It's possible that it's 4, but that messes up and makes us have all kinds of funky stretches. The next thing, you can use A. I think on the quiz I used K for the stretch, so I'm going to use K today. Then what you have to do to find the stretch is put in another ordered pair, and they conveniently gave us one right here, okay? We're going to put in this for X and this for Y to find the stretch. Anybody know something about that stretch right now? We have a degree 4. It needs to be negative, yes, because both ends are going down. All right, but to find it, I'm going to put in 0 for all the X's. I love when we get to put in 0 because it's not complicated to put in, right? And then over here, I am going to put in the negative 25.2 for the Y. Then you can type all of this in your calculator. or do it in your head if you can. This would be 4, this would be 1, this would be 9 after you squared it. So I got 36. Did anybody type it all in and get a 36? You literally can type parentheses 0 plus 4, parentheses 0 plus 1, parentheses 0 minus 3, parentheses squared. And it should all go down to something. Did someone get 36? Okay. What do we need to do to find k now? This is a decimal. For some reason, mine looks like it's a multiply. We just need to divide by 36. And I don't remember what we get. Negative 0.7. Okay. If you did a math enter 7/10, it doesn't reduce. Did someone else get that when they divided? Okay. So final answer is the equation of this polynomial is negative 0.7 and x plus 4 somewhere in your list of factors and x plus 1 somewhere and an x minus 3 quantity squared. That seemed pretty easy? Not too bad. We've been doing these for a while with other kinds of polynomials. It is a nice question to plug in your calculator. Does that seem like I've already got that one in there, guys? Okay, the thing is, if you want it to look like your, the one on the graph paper, you have to kind of set your window like they did. They have like, what, maybe negative 6 to 6 and negative 50 to 50 or something. So if you set your window to be roughly what they did, and graphed it, then it should look something like that. Does that match up the idea that we're getting? And then the other thing, was it negative 1 or positive 1? It was 0 we put in, right? Yeah. I could go trace 0 and make sure it's going through that point that they said. Okay? So these are pretty easy to check if you got the right solution. All right, let's see how quickly. What are we probably going to want to use here? Anybody? This is 0.3 repeating, which we should probably use 1/3. I will not give you a repeating decimal on a test or quiz, but we're going to use 1/3 for that to be more exact. Otherwise, we'll get a real funky stretch. All right, do we have any bounces this time? Nope. Anybody tell me a factor? Oh, he's being all spiffy. I would have used x minus 1/3. Okay? Jack said this. Does that work? Does this give you 1/3 if you set it equal? Okay. So either one of these. Now, are you going to get the same stretch if you use both of those? This one already has a coefficient of 3 in here, right? So you're going to get a different stretch. It'll be an equivalent equation. It's just that the 3 is in here instead of, we might get a 3 out front or something, okay? So I'm going to just use the minus 1/3, but we'll see. At the end, I'll talk about the other answer. Okay. How many? It looks like it has 3 zeros. One of the factors, I'm going to go with x minus 1/3. Anybody have the other two? X plus 2 and x plus 4. Good call. Everybody good? There's one here, here, and here. So what's the other point we might be able to put in because they labeled it for us? This guy, negative 112. Unfortunately, it's not a 0. It's a negative 1. So we're going to put in the 12 for the y. And for all the x's, we're going to put in a negative 1. This is x, this is y. And then, again, you can just go to your home screen and type it all in. It looks like I did that and got negative 4 earlier today, but this would be 1. This would be 3. This would be negative 4/3. So I think when I multiplied it all together, I got negative 4. Did anybody else get that? You can type it in just all at once. But if I divide both sides by negative 4, I get k is negative 3. Okay, so I came up with negative 3 times x plus 2 times x plus 4 times x minus 1/3. Jack, or anybody who wrote this one as 3x minus 1, would have come up with just a negative 1, I think. Is that right? Because if I FOILed this all out, it's already going to have a coefficient of 3. Did you try it and it came out with a... Okay. Should come out with a negative 1 still. All right, ready to try another one? All right, what's the trick on this one? Yes, it's going through 0, 0, and it's doing what there? It's a bounce. So can anybody tell me the factors? We're going to have a factor of x plus 4, good. X minus 2. And this guy, you could write as x minus 0, okay, with a squared, or you could just write what? Yeah, you could just put a plain old x squared out front. It won't matter. Won't matter. All right, and then there's some stretch. Now, does anybody know why we can't put 0, 0 in? There's no stretch at 0, 0, right? There's no stretch at any of the zeros. It hasn't stretched vertically at all at those points. So they gave us this. So we're going to put in a negative 13.5 for the y. And a negative 1 for the x. Be careful when you square that, it'll become 1. Do your math there and see what you get. I got negative 9 on that side. Did anybody else get negative 9? It seems right that when I divide, it's going to become positive, right? 13.5 divided by 9. 1.5 or 3/2. So then you'd put the 1.5 back in right there. I'm not going to take time to rewrite it. Anybody have a question? And how could you check if you did it right? Put it in your calculator, graph it, make sure the window is working, and make sure all of those points are on your graph or in your table for that matter. Okay. Last one. What's going on here? What even or odd degree? Odd degree, because the ends are going opposite directions. Positive or negative leading coefficient? Yeah, negative. A cubic looks like this. This one is upside down. It also has extra loop-de-loops. Okay, so a 0 at negative 2, so there's a factor of x plus 2. Does that have a multiplicity other than 1? No. Where's another 0? At 0. So x minus 0, I'll write it that way this time if you want me to. Does that one have a multiplicity other than 1? Does everyone understand that it comes up here, it does not cross, it just touches and goes back the same way. So that is a squared. It's called a bounce. And then it has another 0 out here at 4. So what would that factor look like? X minus 4, and it is also bouncing there. So what degree do I currently have? I I have an x that's squared, an x that's squared, and an x. Yes, that is a degree 5. That's looking okay, right? Except I'm thinking it has a negative coefficient, which we should be able to figure out. What point do they give us? This one? -1, -5. Okay. So we're going to put that in for x, that in for y real quick. I got 25. Did anybody get 25 on that side? I'm not going to rewrite it. That would become a 25. So you divide both sides by 25, which is, I think, a -1/5 or a -0.2. Whoops, that one's not squared, Hofbauer. Did you get that, Jack? Did I do something wrong? Oh, gotcha. You can use -0.2. I also wrote it with a -1/5. Either one is fine. Any questions on this? Okay. So the practice on this is to do worksheet 6B. You can circle them right now. Problems 1, 3, 4, and 5. I'm going to stop the video, but I am also